Okay, question 25 left to do here. Student is trying to solve 1 plus x squared is greater than 1 plus x squared, no, 1 plus x squared. Okay, and so the student has written 1 plus x squared, 1 plus x in brackets squared is equal to, multiplying out the bracket, 1 plus 2x plus x squared, and then they've written, so 1 plus x squared is less than 1 plus 2x plus x squared. Find the error they have made in their proof. Okay. So it would look like they have multiplied out their bracket, fine, and then they've written that equal to there, fine. But what else could happen here? Ultimately, they haven't defined a range of x, it looks like. If you were to bring this through, you could bring the 1 across and you could get 0 plus x squared less than 2x plus x squared, and then you could bring the x squared across, you get 0 is less than 2x. And you think, well, yeah, that's got to be bigger than 0. What if x equals minus 6? Then you get 0 is less than minus 12. Not correct. Okay. So you can see there that when any x is negative, it doesn't work. So the assumption is that x is positive for A. And in terms of a counterexample, I've just done it there with x equals minus 6, anything that is not positive. Okay. Yes. All right. Not question, but challenge now. So it looks like we're going to go and prove pi by the looks of it. What just happened there? Challenge question. So the diagram shows 2 squares and a circle. Okay. It looks something like this. There's 1 square like that. It has a circle like this, and then it has another square inside of it. How am I going to draw that one? Oops. Another square inside of it, something like that, which has got rotated by 45 degrees, and it sits in there like that, and then it sits something like that. Okay, and it's meant to touch on the corners there like that. Okay, and so they have said, given that pi is defined as the circumference of the circle, so the circumference is equal to pi, okay, of a circle of diameter of 1 unit, and the diameter is equal to 1, then prove that 2 root pi, prove that 2 root 2 is less than pi is less than 4. Okay, so putting that onto here, we are saying that the entire diameter is 1, okay, and that the circumference of this circle is equal to pi. So we can say, let's go for A, B, C, D, E, F, A, B, C, D, E, F, G, and H. Okay. Right then. So the perimeter of A, B, C, D is equal to 1 times 4, which is equal to 4. We can say the perimeter of E, F, G, H is equal to, what we actually need to find out here is we've got a square and we need to find the length of the side. So because it is a 45-degree triangle, we can say that 1 squared not 1 squared, it is 1 squared, but 1 squared equals the length of the side, which is, let's call it x for the moment, squared plus x squared. So we end up with 1 equals 2x squared. So we end up with a half. Square root of a half is equal to x. So this is the square root of a half. The sides in here were 1. Okay, so what do we have? We've got the square root of a half times by 4. And the square root of half times 4 is like pretty sure it's root 2, but anyway, times 4 is 2 root 2. So the perimeter of that smaller square is 2 root 2, and so we can see that the perimeter of this one is proved that. So now that we have been told the circumference of the circle, we can say that shape A is definitely bigger than the smaller square, and so it stands to reason that since the circle is pi, that is 4. Okay, by similar constructing regular hexagons inside the outside circle, prove that it is 3 root 3. By putting regular hexagons inside the circle. Okay. Inside and outside of the circle. So presumably, if we have a hexagon that, do I have a hexagon shape? Of course not. All right. So a hexagon, 6 sides. 1, 2, 3, 4, 5, 6. Okay. And then if we put a circle on there, now if we draw a circle, it touches the edges of it. Yeah, so if we do one that touches there, so there's my circle that just touches the inside of it, and equally I can then put a circle inside that just touches the corners of it. So it would be I don't think that's got enough sides. So another hexagon. Okay. So in the same way, if we say the large hexagon hex perimeter has got to be greater than the circle perimeter, and that's got to be bigger than the small hex perimeter. Okay, and if we say for a start that the circle perimeter is equal to pi times diameter, which is equal to pi, because we are going to set the diameter of this circle in here as 1. Okay, we can now do, if the circle is that, we can now say that the small perimeter, the small hexagonal, has a perimeter. If this is side 1, this is also 1, which makes this 1 as well. So the small hex perimeter is equal to 6 times 1, which is equal to 6. Oh, sorry, 2 pi. 2 pi. There you are. And then the large one, what we need to do here is we need to quickly look at the we need the perpendicular height of one of these triangles here. So we've got a triangle that is 60 degrees, 30 degrees, 30 here, 60 here, and it has a hypotenuse of 1. Okay, with that in mind, we've got a side here of a half, and so square root of 1 squared minus a half squared is root 3 over 2. So we've got root 3 times 6, root 3 over 2 times 6, which equals 3 root 3. Okay, so we've got this down to now 6 is greater than 2 pi, which is greater than 3 root 3. Okay, and formula. I think I've done something wrong there. Messed up my triangle there. It's not 1 on that. That should be a triangle with a 1 here, and I'm looking for x here. Okay. So the sine of, or the cos of 30 is equal to 1 over x, therefore x is equal to 1 divided by cos 30. X is equal to, what's 1 divided by the cos of 30 is 2 root 3 over 3. So 2 root 3 over 3 times 6 is 4 root 3, which is 4 root 3. is less than 2 root 3, which is what it wanted for part B. Okay, sorry about messing that triangle up there. I should have drawn my hexagon better. Finally then, question 2. In the challenge, prove that f of x, which equals ax cubed plus bx squared plus cx plus d, and f of p equals 0, then x minus p p is a factor. So, if we put p in, if we do f of p, we can end up with ap cubed plus bp squared plus cp plus d, and that will equal 0. Next we will do the division, so we will take x minus p and we will divide it into ax cubed plus bx squared plus cx plus d. So what do I need there? I need to multiply by a ax squared, and that will leave me in ax cubed minus apx squared. Bring the cx down, change the signs, so we end up with an a plus b ap plus bx squared. Yep, and so to get this one, we're going to multiply by a ap plus bx. So that gives me an ap plus bx squared minus what does that give you? P times ap plus b c just x. Change the signs. And so we end up with p ap plus b plus c x plus d, bring the d down, and finally we divide by, or we multiply by plus p ap plus b plus c to give me all of that, pap plus b plus c x minus p times ap plus b plus c. Okay. And when you do the Change the signs on that. Plus and minus, that's all gone. And so we end up with P, AP, plus B, plus C, plus D. Okay, as a remainder. Let's get all of that tidied up a little bit. So, multiply out the first bit, P times AP squared plus PB plus C plus D, and then finally AP cubed plus PB squared on the P plus CP plus D. So here's the trick to it all. You can now hopefully see that the remainder given is AP cubed B P squared CP plus D. And we were told that f of P equals 0, and f of P is the same as AP squared plus B P squared plus CP plus D. So, because we have now divided this, divided x minus p into the ax squared plus bx squared plus cx plus d, and we've got a remainder that is equal to 0, we have no remainder. Thus, you can divide x minus p into the cubic and get 0 remainder. So, thus, remainder is equal to 0 from f of p equals 0. Thus, x minus p is a factor because it divides into it and gives you a remainder of 0, i.e. no remainder. Divides perfectly in, must be a factor. Okay, and that's the end of question 2.